In this video, I'd like to explain the intuition of a slightly different formula for compounded interest. So we have this formula that the payment at a certain time is equal to the initial payment times 1 plus the interest rate divided by m to the power of m times t. And I'd like to go through it. I'd like to explain what this means. So what is the difference between this type of compounding and the regular type of compounding? Let's give it again with an example. Remember when we had, for instance, $1 and we want to get 10% on it. Well, if we would get 10% for $1 at the end of a year, we would eventually have $1 plus 10% of it, and we would have $1.1. So that would be the simple case. But suppose now that we have this different example where we have $1 but we compound it 2 times a year. So instead of having 10% per year, we're compounding it in 2 pieces of 5%. So after 6 months, we're compounding it into 5%, and we're reaching to a point of, let's say this is a half of a year, we're reaching to a point of $1 plus 5% of $1, and that's equal to $1.05. And then for the other half of the year, we compound it again into $5. So this we compound it again into, 5%. That's for the second half of the year. So what do we have now? Well, we already reached to a point of $1.05. So now we have $1.05 plus another 5% of $1.05, and the result would equal to, let's actually calculate it real quick. That would be 1.05 plus 0.05 times 1.05, which is 1.1025. What is 1.1025? What did we actually compound here? Let's write it. Let's write the math behind what we just did. Well, look, what we just did was that we had $1 and we compounded it by 1 plus 5% twice. So we had 1 plus 0.05 to the power of 2. Now, this looks like our regular compound formula, but I would like to write it in terms of this equation. How would that look like, where we have 1 plus I over m to the power of m times t? Because I'd like to understand the intuition of what's going on here. Well, what is 0.05? We could actually write this as, we can write this formula as 1 times 1 plus 0.05. Well, that was just our 10% divided by 2 to the power of 2. Do you see the relationship? This is our m in the formula. If we look at the formula where we write pt equals to p0 and we have 1 plus interest divided by m times t, well, what we have here is the conversions in one period. So basically in 1 year, how many times are we compounding the interest? And in our case, we're compounding the interest 2 times per year, and it makes sense. We have 10% divided by 2, which is 5% per period, compounded twice, so we have to the power of 2 times per period. So 2 times 1 year, but we're compounding the interest twice. And that is the intuition behind it. That's how we get to this 1.1025. The whole notion is that we're still having a compound interest formula, and we can write it as a compound interest formula with 1 plus 0.05 to the power of 2. But it's very wise to understand where this is all coming from, and it's just coming from the fact that the annual interest rate is subdivided into several parts, and the number of parts that is divided is usually this m value, and we're taking it to the power of that m value because we're compounding the interest per every period. I hope this makes sense, and in the next videos we'll solve a question on this topic.